New groundbreaking research has revealed that our previous estimates of Betelgeuse's size and evolutionary timeline have been significantly underestimated. According to this research, Betelgeuse could go supernova in just a few decades, rather than hundreds of thousands of years. This is significant because Betelgeuse is located 650 light-years away, which means that the current appearance of the star reflects its state as it was 650 years ago. If it does go supernova, we could see it within our lifetime. So, let's dive into this intriguing new study and its groundbreaking explanations. But first, let's recap what has happened before. Betelgeuse has been a star of surprises in recent years. In 2019, it dimmed significantly, leaving scientists baffled. The mystery was eventually solved when astronomers discovered that a massive cloud of gas had been ejected from the star's surface, blocking our field of view. The origin of the cloud is still unknown, but scientists are divided on two possible explanations. Either a large object passed close to the star, or the cloud was created by the star itself. But even more recently, Betelgeuse has become almost 50% brighter than usual, making it one of the brightest stars in the night sky. In search of a better understanding of Betelgeuse's behavior, scientists have analyzed its variability periods. New research into Betelgeuse's fundamental and overtone modes of pulsation has led astronomers to revise their understanding of its size and evolution timeline. But what does that mean? Let's explain it in a simple way. Stars are not just static points of light in the sky. Instead, many of them continuously pulsate, expanding and contracting rhythmically. It's similar to the way a heart beats, expanding to fill, then contracting to release. These pulsations happen because of the complex interplay between gravity and internal pressure within the star. Let's imagine two stars to understand the different pulsation modes. First, there's star A, which undergoes fundamental mode pulsations. In this mode, the entire star uniformly expands and contracts, like a rhythmic breathing motion. Picture the star gradually swelling in size and then contracting back to its original state in a regular and synchronized manner. This fundamental mode is associated with the star's essential parameters, such as its mass, size, and age. Astronomers study these pulsations to gather vital information about the star's fundamental characteristics. Now consider star B, which exhibits overtone mode pulsations. In this case, the pulsations of the star are more complex and involve different regions pulsating at varying rates. Some parts of the star may expand and contract faster or slower than others, creating a more intricate pattern of oscillation. By studying these overtone modes, astronomers can gain insights into the internal structure of the star, including its density distribution and composition. These modes provide additional details about the star's dynamics beyond the fundamental mode. Over the centuries, astronomers have meticulously observed Betelgeuse and documented its intriguing semi-regular variations. These observations have revealed the existence of 4 distinct periods in its pulsation: 2200 days, 420 days, 230 days, and 185 days. Initially, scientists postulated that the 420-day pulsation cycle was the fundamental mode, with the shorter cycles serving as overtones. Furthermore, the enigmatic 2200-day cycle was regarded as a lengthy secondary pulse of unknown origin. This understanding led researchers to estimate that Betelgeuse's size could span the impressive range of 800 to 900 times that of our Sun, an immense scale comparable to reaching the outer edge of Jupiter. However, a groundbreaking research paper by Sayo and colleagues challenges this long-held belief by presenting compelling evidence that the 2200-day cycle is, in fact, the fundamental mode, while the other 3 cycles represent its overtones. This astonishing discovery indicates that Betelgeuse is significantly larger than previously estimated, extending over 1,200 times the size of our Sun, surpassing even the orbit of Jupiter. The revelation of Betelgeuse's true scale reshapes our entire comprehension of this extraordinary star and revolutionizes our knowledge of its internal processes. Recent research suggests that Betelgeuse is nearing the end of its lifespan and is poised to undergo a supernova. This is because the star has almost depleted its carbon reserves, a crucial element for its nuclear reactions. During the main sequence phase, which lasts around 10 to 12 million years, a star like Betelgeuse converts hydrogen into helium in its core, accounting for 90% of its lifespan. This process occurs at an extremely high temperature of approximately 15 million Kelvin. As the star exhausts its hydrogen supply, it enters the red giant phase. In this phase, gravity causes the core to contract and heat up while the outer layers expand and cool, giving the star its reddish color. When the core temperature reaches around 100 million Kelvin, helium starts fusing into heavier elements like carbon and oxygen. Over time, the core develops an onion-like structure with different elements, with the heaviest at the center and lighter ones in surrounding shells. Once the core temperature becomes sufficiently high, carbon and oxygen undergo fusion to form even heavier elements, including iron. However, iron fusion is different as it absorbs energy instead of releasing it, resulting in an unstable core. This instability marks the star's inevitable demise. For a star the size of Betelgeuse, the process of fusing carbon into heavier elements in its core takes roughly 1,000 years. Precisely determining the remaining amount of carbon in the core of a star, like Betelgeuse at this stage, is challenging. Nonetheless, studies of Betelgeuse's pulsations and brightness have provided indications that its core contains only between 0.48% to 17% of carbon. This implies that a significant portion of Betelgeuse's carbon has been consumed, and from our perspective, it may explode into a supernova within a few decades. It's worth noting that the explosion may have already occurred in real time. Observations of Betelgeuse have revealed significant changes, such as a surge in brightness of over 50% above its typical luminosity since the beginning of the year. Additionally, the star has lost its 420-day pulsation cycle, a characteristic it has exhibited for several centuries. These anomalies further emphasize that Betelgeuse is undergoing something unusual. Supernova of a Betelgeuse will be an extraordinary event. The star's brightness will increase dramatically, potentially becoming brighter than the full moon. It may even be visible during daylight. The supernova will also release a massive amount of energy, which will travel through space at the speed of light. The light from the supernova will be visible to the naked eye for an extended period, possibly over a year. However, the brightness of the supernova will gradually decrease over time. After a few months, the supernova will be as bright as a faint star, and after a few years, it will be too faint to be seen with the naked eye. It will be a once-in-a-lifetime opportunity to witness the death of a star and the birth of a supernova remnant. In addition to the light from the supernova, there will also be other effects that can be observed from Earth. For example, the shock wave from the explosion will travel through space and cause the surrounding gas and dust to glow. This glow will be visible in the form of a nebula, or cloud of gas and dust. Fortunately, the substantial distance between Betelgeuse and Earth ensures that our planet will not experience any detrimental effects from the explosion. Scientists have recently made a startling discovery about the age of the universe. Using data from the James Webb Space Telescope, they have calculated that the universe is 26.7 billion years old. This is significantly older than the previous estimate of 13.8 billion years. If you want to learn more about how scientists reached this conclusion, watch this episode and subscribe to our channel for more updates. See you next time.